Hello, this is Dr. K. In this video, I'm going to introduce you to a few simple concepts regarding inheritance that I don't think are always adequately represented in some of the major textbooks. The first concept I want to talk about is this notion of type hierarchy. A type hierarchy, as mentioned here, is just a family of types represented with one supertype at the top of the hierarchy and all of its subtypes. So, for example, everything in Java belongs to the object type hierarchy, since every class is either directly or indirectly a subtype of object. But what I want to really draw your attention to is the two bullets underneath the type hierarchy definition. Because although there are many different kinds of type hierarchies, these are the two you're going to see most often. The first is the most common. That's where the subtypes extend the behavior of their supertypes. For example, the subtype might provide extra methods that the supertype doesn't have, or the subtype might override a supertype method. In these type hierarchies, it's not necessary for the supertype to be abstract. In other words, the supertype doesn't have to be an interface, or it doesn't even have to be an abstract class. It can simply be a regular, concrete class that's capable of being extended. The second type of type hierarchy is very distinct. It typically involves an interface and at least two different implementations, which are concrete classes of that interface. Furthermore, it often involves an abstract class that the concrete classes inherit from. Now, that abstract class is where secondary methods are implemented. Secondary methods are methods that do not depend on a particular representation and can be implemented using other, more primitive methods, rather than using instance variables. Let's look at the most common form of inheritance structure first. We've got a concrete class, doctor, at the top of our type hierarchy. It has one field or instance variable named works at hospital, and it has one method, treat patient. There are two subclasses in this diagram. One subclass, surgeon, overrides the treat patient method, presumably because their treatment entails opening the patient up. The surgeon class also extends the doctor class with a new method called make incision, which perhaps is called by the treat patient method. The other subclass in this diagram is family doctor. Family doctor adds a new instance variable beyond the one instance variable, work at hospital, that it inherits from doctor. It adds the field makes house calls. In addition, it adds the method give advice. So let's think about what fields and methods are available to us in each class. If we are a doctor object, we have one field and one method. And if I give you 5 seconds, can you tell me how many fields and how many methods a surgeon object has? 5 seconds starting from now. Okay, a surgeon object has one field, the one it inherits from doctor, and it has two methods, the one it overrides and the one it adds. How about a family doctor object? How many fields and how many methods if I give you 5 seconds starting from now? A family doctor has two fields, the one it inherits from doctor and the one it adds. And a family doctor also has two methods, the one it inherits and the one it adds. The other kind of type hierarchy that I want you to be familiar with is the one that you see all the time with data structures and algorithms, where you want to be able to have multiple implementations for the same interface. What you see here is a simplified example of a list hierarchy. The list interface at the top of the hierarchy contains all of the methods you need to behave like a list. If you're using a list, you only need to go to the Java docs for the list interface in order to find out how your list will function. However, there are at least two popular implementations for the list interface. These implementations behave functionally in exactly the same way. They differ when it comes to their performance. An array list is really fast at accessing the elements of a list once the list has been created. And a linked list is really fast at adding elements to and removing them from the beginning or the end of a list. This concept of multiple implementations with different performance profiles is usually not that difficult for beginning programmers to understand. What is sometimes difficult for beginning programmers to understand is the role of that abstract class that sits right in the middle of the list interface and the concrete implementations of the list. What is its purpose? Why do we need it? Well, in order to explain that, we have to understand the distinction between a primary method and a secondary method. A primary method is a method whose implementation absolutely depends on one or more instance variables. Remember that the instance variables, which are private, determine how your class is implemented. An array list will include an array as one of its instance variables, and a linked list will include a node as one of its instance variables. So the instance variables comprise the internal representation for the object. Some methods depend on instance variables. For example, you cannot implement the add method for a list without using one of the instance variables. That means that the array list and the linked list are going to implement the add method in two very different ways, because they have different instance variables. However, when you go to implement the add all method, you quickly realize that as long as you have a get method, an add method, and a size method, you can simply iterate through the list you're adding from, get each element one at a time, and add it to the current list. The main point here is that you do not need to depend on any concrete representation. There are no instance variables involved in the add all method, or at least there don't have to be. If there are no instance variables involved, that means that the add all method is implemented in the exact same way, whether you're using an array list or a linked list. Therefore, instead of having duplicate code in both the array list and the linked list classes, which is almost always a bad idea, we can implement the add all method in an abstract class. Now, sometimes you might want to override secondary methods because you can implement them more efficiently as primary methods, but it's almost always a good idea to have default implementations of all methods that can be implemented as secondary methods in an abstract class. Here's one more distinction I don't see emphasized enough in most textbooks: the distinction between apparent types and actual types. The apparent type of a variable is the type it is declared as, while the actual type of a variable is the type it is initialized as. In these examples, Marcus Welby and Hawkeye Pierce are both declared as doctors, so their apparent types are doctor. But Marcus Welby is actually a family doctor, and Hawkeye Pierce is actually a surgeon. Likewise, my list and your list are both lists of strings, so that is their apparent type. But my list is actually an array list, and your list is actually a linked list. Apparent versus actual type is a critical distinction, because when Java does its type checking at compile time, it has to rely on the apparent types of the variables in order to see if there are any type violations. But when the program is running, the actual types are used to determine what code to execute. For example, if treat patient is called on Hawkeye when the program's running, the patient will be operated on. But if treat patient is called on Marcus Welby, the patient's going to get a couple aspirin and told to call back in the morning. And that's it for this brief discussion of Java inheritance concepts that you may or may not have picked up from your standard textbooks. I'll see you in the next video.